Okay, in homework question, practice problem number 1 from section 6.3 on page 286. We have a sample of aluminum, a 2 kilogram sample of aluminum at 100 degrees Celsius that is placed in 1.5 kilograms of ethyl alcohol at 18 degrees Celsius. In this question, they're asking us to find the final temperature of the mixture. In order to do so, we're going to have to use the principle of heat exchange, which states that the energy released plus the energy absorbed is equal to 0. So let's sub in these quantities. Using the variables that were given. We know that the aluminum will be releasing energy, and we know that the ethyl alcohol will be absorbing energy. So we can state that 0 equals the mass of the aluminum times the specific heat capacity of the aluminum times the change in temperature of the aluminum plus the mass of the ethyl alcohol plus the specific heat capacity of the ethyl alcohol times the change in temperature of the ethyl alcohol. Here we know that the initial temperature of the aluminum was 100 degrees Celsius, and the initial temperature of the ethyl alcohol is 18 degrees Celsius. So we're going to have to solve for T2. T2 is in 2 spots in this equation, so we're going to have to use the distributive property. So we're going to multiply MACA times T2 and MACA times negative 100 degrees Celsius. Then we'll multiply MECE times T2 and MECE times 18 degrees Celsius. If we do so, we get 0 equals MACA T2 minus MACA 100 degrees Celsius plus MECE T2 minus MECE 18 degrees Celsius. Our next step in solving this is to collect like terms. So we're solving for T2. So this term has a T2, this term has a T2. Everything else we're going to send across the equal sign. So we end up with MACA T2 plus MECE T2 equals, and when we bring these terms over, they will become positive. So we have MACA 100 degrees Celsius plus MECE 18 degrees Celsius. So we've collected like terms on the left-hand side. We have T2 in 2 spots. So at this point, we're going to factor. So we'll factor T2 out. We have T2 MACA plus MECE is equal to MACA 100 degrees Celsius plus MECE 18 degrees Celsius. Now to solve for T2, we're going to divide both sides by this term here, which is MACA plus MECE. And we're left with T2 is equal to MACA 100 degrees Celsius plus MECE 18 degrees Celsius divided by MaCa plus MECe. And now we can sub and solve for T2. So if you plug in all of these variables and you very carefully complete this tedious equation, you'll find that the final temperature of this resultant mixture is 45 degrees Celsius.